math just today. There is no math on Wednesday this week. So just classes Monday and Tuesday this week. The rest of the week you are off for Thanksgiving. So I'm glad you guys could make it. We're going to finish up last week's work. And yeah, just make sure we have a good understanding of how to do graphing, okay? Before we just continue on with that. The week that follows, so next week will be our last week of new information. And then we're going to use our final week of class to kind of review and get ready to wrap everything up. Okay, so we're going to start with this week's announcements since we don't have a pre-assessment to do because we did that last time, right? Um, all right, so always make sure to check the homeroom for weekly announcements. You can always reach out to me if you have any questions about anything that's posted on the homeroom. This week, we will only have on-site support today until 4 p.m. And then next week is the last week for on-site support. That will be next week, Monday and Wednesday, December 2nd. Is the last day for on-site tech support. So if you need help with one of your with your device and you're not getting the help that you need via the phone, you can go in to get that help. If you are having any other questions, you need to reach out to someone, make sure that you call the number that I'm going to put into the chat. Leave your name, your phone number, and your reason for calling, and they will get back to you within 24 to 48 hours. That number is 202-289-6623, extension 128. Always make sure to check your AOH emails regularly because that's where we will share information as well. And the trivia will be posted tomorrow. Congratulations to last week's winners, Amber Gross Gray and Arlene Hawkins. All right. So with that done, we are going to get.
But question no. You're saying that the question will be in the homeroom, yeah?
Correct. Yep. That's where the trivia is always posted, in the homeroom.
But then so on her page, I mean, call your page, yeah?
So it'll be posted in the homeroom.
Yeah, I'm still trying to find the homeroom, man.
So it's the course that says Ward 8 homeroom. So when you go to your courses, you're looking for the course that says Ward 8 daytime homeroom.
Okay.
Do you see it?
Now again, I'm about to turn. Just see. Just settle. Hold on, down. Ward 8 homeroom. Okay, yeah. Then shoot, then I why it didn't start.
Yeah, no worries. Good. I'm glad you found it. All right. So let's get into today. You see, I already have a question up here for us. So what is the difference between a horizontal line and a vertical line? What's the difference between a horizontal line and a vertical line?
Okay. Okay, so the way I think I know by with vertical line, I know vertical line they usually they go straight across. They go vertical line, they go straight across, and then also with the horizontal, which they go basically that they going differently. That's how I think.
So which one goes straight across?
Vertical that the vertical. Vertical is go one that go. Well, I know they say how they say the left go across basically just left to right, and then also and then also with the X, and then you go right on top that the horizontal.
Okay, so the one that goes straight across or left to right
Yeah.
is your horizontal line,
I just
right? Horizontal goes straight across, left to right, right? Like a flat line. Okay, the vertical line, vertical is straight up and down. Okay, so horizontal is left to right, vertical is straight up and down. And so which one is the x-axis? Is it a horizontal line or a vertical line?
I'm gonna say X. Probably might say X at the you know.
So x-axis is the one that goes left to right. So it is a horizontal.
Horizontal, yeah.
Okay, good.
And I guess Y is vertical, and then Y.
And then y would be vertical. Exactly.
Yeah.
That's correct. Okay. All right. So we're going to open back up our notes from last week. And then we're going to go into some of the practices so that we get more comfortable with it. And then after, we're going to do a little bit of a challenging practice to give us some more work, and then we'll see where we are after that. Okay. All right. So let's get into our Schoology course. So if you, again, you're in your Math Skills 4, you're going to make sure you go to the only red folder for week 9, right? Which goes until today's date. And you want to click on the Intro to Graphing Notes, which is the 5th thing in that folder, Intro to Graphing Notes. And it has the recording from last week. And also, we are going to finish the bottom part of it. So we're going to open it in Kami. Sorry, I have to sign in. I have not signed in yet today. It's always a good idea to sign in before class, but I hadn't signed in yet for the day. Okay, so these are our notes from last week. I'm actually going to scroll all the way down to the last page, page 5 at the bottom. We are going to work through these exercises here at the bottom.
You said these are not week 9 folders, Mr. G?
Yep, it's in your same week 9 folder, the same red folder that we were working in last week. We're still working in that folder this week.
Okay, let me see. Yes. All right, and which one was it?
It's the Intro to Graphing Notes.
Okay, I'm in there.
Okay, great. All right, so we're on the last page, page 5, at the very bottom of that page. We are going to try to identify the ordered pairs that are solutions to this equation 2x plus y is equal to 10. All right, so we have to do a couple of reminders in order to do this properly, right? So let's start with those reminders first. Okay, so remember that each of these things in parentheses are known as an ordered pair, right? That's what each of these things in parentheses are. They are an ordered pair. Also, we have to remember that the x value comes first, and then the y value is second. So it's x comma y. We're trying to find the ones that are solutions to this equation 2x plus y equals 10. So basically what we're trying to figure out is that if I replace the x with the x value and the y with the y value, I should be able to get 10 as my answer. If I do get 10 as my answer, then it is a solution. If I don't get 10 as my answer, it is not a solution. And so I'm trying to circle the ones where I do get 10 as my answer. So basically what I have here is my x is 8, my y is 2, right? When I replace that in my equation, I have 2 times 8 plus 2 is equal to 10. Is that true? No, it's not, right? Because 2 times 8 is 16, and 16 plus 2 gives me 18. So this one is not a solution. So I can cross it out. It's not a solution. All right. So that's the idea here. If to take each one of these and see if they are solutions to our problem. All right. So we'll try the next one. 4 and 2. Is 4 and 2 a solution here? You guys tell me. I'm gonna replace that 8.
Okay, so I would say, okay, let me just say this. If you, maybe you would try like 4 and 2. Let me know. 4 and 2. Maybe know.
Okay. So is it a solution?
Yeah, that's solution. Are you
What
guys
do you get? What's 2 times 4?
2 times 4 is 8.
Okay.
Then
Plus
plus 2, it'll give you 10.
Perfect. That's what we're doing. All right, good. 2 times 4 gives me 8. 8 plus 2 is equal to 10. It works. So I will circle this as a solution. That is a solution to my problem. What about this next one? 8 and negative 6. When I put in 8 and negative 6, 8 for x, negative 6 for y, do I get 10? 2 times 8 is?
2 times 8 is, I don't know 2 times 8 is 18, but.
All right, what about 16 minus 6? Does that give me 10?
No. Basically, just give you another number. That
What's 16 minus 6?
22.
16 minus 6 is 22?
16 minus 6. No, wait, hold on. That's a negative.
It's 10. You said 16. Oh, you said 16 minus 2. My fault. Ooh,
No, I said 16 minus 6. I said 16 minus 6.
Oh.
You're right. It's 10, right?
Oh, and 10. So now.
I'm sorry, Miss G. I'm having a long morning.
It's early, huh? It's early on this Monday morning, ain't it?
Don't rub it in.
It is early on this Monday morning.
Okay,
I'm like 16 minus 2, huh?
Oh, you said 16 minus 2?
No, I said 16 minus 6. It's 10. Don't worry, we got it. So yes, the first two are solutions to our problem. It's all right, y'all. We're all here together. It's all good.
Yeah, that's wrong.
Okay, let's try this next one. We have negative 2 and we have 6. So 2 times negative 2 will give me what?
E multiplied by give you negative 16.
2 times negative 2.
Oh no, negative. Oh no, then that give you 4. That's not. No.
That's negative 4. Okay, negative 4 plus 6 is going to give me what?
Negative 4 plus 6, and give you go down. What is it? That give you negative.
We're gonna give you negative 10.
Yeah.
Negative 4 plus 6.
Oh no.
You have 4 negatives, but you have 6 positives. How much do you have?
It's gonna be a positive 10 then.
No.
It's going to be 2.
2. That.
Oh, negative 2. Oh, I'm on here. I was saying you way wrong, Mr. G.
All right. Wait 1 second. Let me make sure that we're gonna get this.
Negative 2. Oh, what the fuck?
Y'all are scaring me a little bit this morning. So I saw Ebony shake her head and give us the answer, but I'm gonna go ahead and write this out for us. All right, so I have 6 positives, right? 1, 2, 3, 4, 5, 6. But I have 4 negatives, right? 1, 2, 3, 4. So let's go ahead and cancel out the things, the negatives with a positive, right? For every negative that I have, I'm going to cancel out a positive, right? So I have 1 negative, I'm going to cancel out 1 positive. I have 2 negatives, I'm going to cancel out another positive, 3, 3. All right, so now my negatives are all gone and I have 4 positives gone. How many do I have left? How many is there? 2, right? So this is the same as negative 4 plus 6. It's going to give me 2, a positive 2, right? Also, remember you can do it like this. You can draw it out, right? Or you can use your addition of negative numbers rules, right? Which tells you that if you have opposite signs, what you do is you subtract them. So you do 6 minus 4, and then your answer is going to be whichever number is bigger. So it's either going to be positive or negative depending on whichever number is bigger. Because you're dealing with a -4 and a +6, 6 is positive, so my answer will be a +2. All right. So make sure that you guys are remembering those rules, working with those rules. Don't forget them, but also remember there's other ways to think about it. You don't have to use the rule. We could just use some drawing. There are other ways to figure out an answer, right? Okay. That's that one. Let's get back to the assignment. Okay. Let me annotate again. All right, so we figured out that these two are solutions and these two are not solutions. Let's try this one, 5, 5. What's 2 times 5? 2 times 5 is going to give me
10.
10. Plus 5 is going to give me
15.
15. So that's not a solution because I want to try to get 10 only, right? Okay.
Right.
This one, I'm going to plug in 0 for my x. 2 times 0 gives me 0. 0 plus 10 is going to give me 10. So this one is a solution. All right. This one says 5, 0. So 2 times 5 again gives me 10. 10 plus 0 gives me 10. So this one is a solution. All right. This one says 3.5, 3. So 3.5 is what I'm going to replace my x with. So I have 2 times 3.5. What's 2 times 3.5?
That'd be 10. Then one of these 6 points.
It's gonna be 7.
Good. So that's 7 plus 3. What's 7 plus 3?
10.
10. So this one is also a solution.
Oh.
All right. And now my final one is 1, 2. So I have 2 times 1 plus 2. What's 2 times 1?
2.
Plus 2?
4.
So that one is not a solution. So then 1, 2, 3, we have 5 of them that are solutions and 5 that are not solutions. Okay. All right, so a reminder of how to do this. We have to remember that our ordered pair tells us the x and the y value. X is first, y is second. If I'm trying to figure out if it's a solution, I just plug them in by replacing the x with the x value and the y with the y value and seeing if it works in that number sentence. If it does not work, then it's not a solution. All right. Okay. This next part is about plotting points. When it says to plot a point, it means to put the point on the graph. All right, and so we have some locations here, right? These addresses are written as ordered pairs. And again, the information tells us how to move along the x-axis and how to move along the y-axis is next. So with
Hey, Mr. G, I'm sorry to cut you off real quick, but I know we got this on our Camry. Is it possible that I can open a map and just follow you as you go?
What do you mean?
We got this right here that you're doing with us. We actually got this in our folder that you told us to look in our week 9 folder.
Right.
And I was wondering if I open mine up, I can just go over mine how you going over yours with us.
Yeah, you can. Yeah, you should be doing it right now. Yeah, that's the part.
Okay.
Yeah, you should be doing that, right?
Yeah, I'm just so far behind. That's all, Mr. G. All right,
Oh, no,
okay.
okay.
I'm here.
Yeah. Okay.
I'm sorry.
Right.
I ain't even think we was on I ain't even think this is the same paper. I had to scroll all the way down.
Yeah. Yep.
Yeah, but I'm with you, Mr. G.
Okay.
I'm with you.
All right. So let's go ahead and try to plot this first point. I'm going to walk you guys through this one, right? So if it says 1, 2, what I'm going to do is I'm going to start in the very middle, right? Because the middle is 0, 0. right?
Right.
Where the two dark lines intersect, that is the point 0, 0. So from there, that's when I can begin my counting. And so I'm supposed to plot 1 and then 2, right? That's where I'm supposed to get my first point from. So that means the 1 tells me how to move left or right. So I'm going to move to the right by 1, right? I'm not going to put my point there though, because I'm not done with the address. I now have to go up by 2. And I know that it's up because it's a positive 2. So from where I moved over by 1, I'm going to count up by 2. And that's where I'm going to put that point, right? That is the point 1, 2. So I've plotted that point. Okay. What about this next point? How do I plot that point? Again, I'm going to start in the middle. In which direction am I going to move first, left or right?
You're gonna move right.
Okay, by how many?
4.
4. I'm going to go to the right by 4. So 1, 2, 3, 4. I'm not going to put my point there though. I have to do the next part of the address. So now what do I do? Do I go up or down?
You go down 2 because it's negative.
1, 2. Perfect. And that's where I put my next point. All right. So that's how you plot a point. So I'm going to go ahead and plot the rest of these, right? So now 0, -3. I start in the middle at 0. I don't have to go anywhere left or right, right? There's no movement left or right because it's 0. So now I just
you go down 3. You
now
go
I
down
by
3.
Yep. Perfect.
I think I get it.
Yep. Okay. Next one, -1, and then up by 3. Next one is -2, up by 1. Next one.
All right, so hold up real quick, Mr. G. Hold up real quick.
Yep.
I noticed you start moving to the. I noticed you start moving to the left. How you get to the left now? Because at first we were just working from the right to the middle, and now you move to the left. That's all.
Uh-huh. What
Is it
happened?
because it's a negative first?
Yep.
All right, okay, I got you. So if the negative first, if it's a negative first that getting called out first, you move to the left.
Correct.
All right, I got you.
All right. This one is 2, 0. 3, -3. 2.5 and 1. All right. I got all my points in.
So how did you do the 2.51? How did you do that one?
Okay, so what is 2.5?
That's apparently that's the positive numbers, right?
Yep, but where is it? How would you describe where 2.5 is?
I'm not sure.
Is it more than 2?
It's 2.5 more than yeah.
Okay. Is it more than 3?
No.
Okay, so I just went to the middle between 2 and 3. Right? So I went over by 1, 2, then went about in the middle between 2 and 3, and then I went up
Right
by 1.
Okay, I got you. I see what you did.
Yep.
I see exactly what you did. I'm sorry, Mrs. G. I got 1,000 questions for you.
No, it's important to ask questions, right? No, ask questions. I'm not mad about questions. Questions are good. Questions are a good thing. Okay, did everybody get their points in? Everybody plotted them?
Oh.
Maybe. Uh-oh, let's see, there's something in the chat. What did I miss? Okay. All right, if everybody got their points in, we're going to move on to the third box, which is to write the ordered pairs for each point. All right, so we're just going to figure out where each point's address is, right? So for instance, for point A, where is point A located? And how do we know? Where do we think it is?
I guess you go up. You go about. It looked like you go up 3.
Okay, I go up by 3. What about my move? What's my movement left to right?
Your movement is going to be to your right. It's going to be to the right.
I didn't move left to right, right? It's on the dark line, so I didn't
Yeah.
move left to right, right?
So probably
you
that would be
did.
0, 0 down.
Okay, so that'd be 0. Okay, so how do I write my numbers in? So I have 0 and 3. Where do I write them? Is 3 first or is 0 first?
It's 0 first.
0 first. Good. And then 3. That's
3.
my location. 0, 3. So your location left or right is what you write first. That's your X location. And then your location up or down is what you write second. That's your Y location. Okay, so for letter A, the location is at 0, 3. All right, what about letter B? Where am I?
That's in the negative.
Zero.
It's in the
There is
negative, but
0.
it's over 2.
Okay, so negative
-2. Actually, -2. That's
2
right.
is my X location. And then Marvin, you said it's 0, right? For my Y location, I didn't move up or down, right? So the
Nope.
location is 0. -2, 0 is my location for B. Very good. What about letter C? Where am I located for letter C?
So
On the right side, up 5.
So, but I have to go left or right first. So let's
matter
go
of
left
fact-
or right. How many do I have to go over to the left?
Oh, you gotta go 3 to the left. I mean the right. I'm sorry, 3 to the
Oh,
right.
sorry, to the right. Yes, excuse me. It's 3 to the right. So 1, 2, 3. So my number is 3. Okay, and how far do I go up?
You go 4.
I go up by 4. Perfect. All right, I'm gonna let you guys do the other ones. I'm gonna give you guys just a minute to do the other ones.
You don't want to help us too much. Come on, Mr.
I don't want
G.
no, of course not. You're gonna have to do this eventually.
It's
So
the only way I can catch on. You gotta walk through it with us.
I walked through 3. You guys have
All right, I got you.
6 more to
I need
do, and
it.
I'll check in with you in a minute. I'm just gonna give you a minute to work on
Hey,
it.
my phone's hurt. Oh no, not you. Let me put my computer on mute. Yes, man.
Okay, where is letter D located? I put that it's at -3, 1. Is that what everybody else got for letter D? Yeah?
Yeah, I did.
Okay. What about letter E? Where is E? I don't see E. Everybody find E? No? I didn't find E either.
Not that I know about. I didn't see no I, J, and I were too. Cause I
What
only
about
thing I
F?
see some saw I and J, but
F? Nope, no Fs. Okay.
no, I don't
G?
see F.
G? H?
No, only I. I
Okay,
see
where's
I.
I?
Now. There's 0 when you. There's only 0, and then you won't see the 0. Then you see 5. I think.
So it's 0, 5 for I?
Oh well, yeah. Can I think I.
So you put 0, comma 5.
Yeah, kind of like that.
Okay, so if it's 0, 5, it would be 1, 2, 3, 4, 5. It would be up
No,
here.
that I think that should go to the right though. I think
Okay, so how do I go to the right?
right. There goes let's see, 1, 2.
So it's 0, 5 is here. This is what I just plotted. That's 0, 5. So what are you trying to say? Where's I?
I right here.
So
I'm
where's
just
I?
saying. I'm saying you're going to the right. You're going to the right like that.
So you go to the right by how many?
That be. I think that's 4. 4. 4.
4. Okay. So then that should be your first number, right? It's 4.
Right.
1, 2, 3, 4. So
Mhm.
4 is the first number, and then we have a comma 0, right?
Yeah. Yeah.
Okay. Yeah, that's where it's 4, comma 0. Right? Whenever we're plotting our points, remember that the x value comes first. Did you move left or right? Your left or right movement is what comes first, and that's the 4, right? And then if you don't move up or down, then it's 0 for your y. Okay? All right. All right, so we don't have E, F, G, or H. Where is J? What is that J? What location is J in? What's that location? It's here in the middle. What is that location?
The origin.
It's the origin. So that's 0, 0, right? Or the origin. Very good. Good work. Okay. All right. Sometimes we will be given a line, just like we have here in this last part. There's a line, and we need to find 4 locations. They want us to find 4 ordered pairs. All right. So the way that you do that is that you look at your line and you find places where it crosses perfectly onto the intersections of some boxes. All right. So for instance, this is a perfect intersection, right? It's crossing directly at an intersection here, right? It is not crossing directly at an intersection here, so I'm not going to use that point. But it is crossing perfectly here, so I will use that point. It's not crossing perfectly here, so I won't use that one. But it is crossing perfectly at this point, so let's use that intersection, and we can also use this intersection, right? There's also other points I can use. Well, one other point that I can use, but it doesn't matter. We're just looking for 4 places, right? And you always want to choose a perfect intersection so that you're not guessing where the location is, right? You can know exactly where the location is. So the location of this first point, to find it, again, I'm going to move along the x-axis first. So I move 1, 2, 3, 4. So it's -4 is the x location. And then I go up by 1, 2, 3. So it's -4, comma 3. That's the first location. My second point, again, I'm going to count along the x-axis first. So it's 1, 2. So that's -2. And I'm going to go up by 1, 2. So it's +2. -2, +2. All right, this third location here, I don't have to go left or right, so it's 0. And then I go up by 1. And then this last location, I have to go to the right by 2. And then I don't go up or down, so that other location is 0. All right, so this is how you find points, right, and write an ordered pair based on a graph, right? You look at the graph, you see where it intersects, and then you locate those points. All right, so we've done 4 exercises that you will be asked to practice at some point in one of your exercises this week, right? What we're going to review right now is practice number 1, which asks you to work with tables, right? We're going to work with those tables first, which was the first part of the notes. I know it's been a while, but that was the first part all the way back up at the top of my notes, all right? So we're going to go over practice number 1 now, and then we will see how we're feeling about tables, right? And then we'll try to do another practice around tables as well. before we are done for today. All right. Okay, let's do it. I'm going to erase that. Go back into my folder, right? So into my week 9 folder, and I'm going to go to the option right after the intro to graphing notes, which is practice number 1, tables and graphs. That's what I'm going to open up right now. Oops, excuse me, sorry. All right. All right, so we have this first question here. It says, Megan walks 3 miles per hour. It says, what is the total D distance she walks after H hours? So what is the relationship between the two variables? So when you're asked, or describe the relationship between the two variables, when you're asked to talk about the relationship between two variables, you're really being asked to identify which variable is independent and which variable is dependent. So if she's walking 3 miles per hour and it's telling you that the total distance D, right, is what she walks after H hours, which variable is independent and which variable is dependent between D and H? What do you guys think? Which one is dependent and which one is independent? Does the total distance that she walked depend on the number of hours that she's walking, or does the number of hours that she's walking depend on the total distance that she's walking?
Identify maybe like a total. Like total. You say what the total, the not the. So I'm gonna take the total kind of not an hour.
I'm
I
sorry, I'm
think
not
H will be your individual verbal,
independent.
independent verbal. My apologies.
No worries.
Yeah.
Okay, so H is going to be independent.
And I think D kind of look like a dependent variables.
Okay, good. So that would mean D would be the dependent variable. So remember that what we're saying here is that what we're essentially saying is that her distance is going to depend on how many hours that she walks. Does that make sense? Yeah, that makes sense, right? So when you're saying that the H is independent, right, you're saying that however many hours she walks will influence her distance, which makes sense, okay? So what is the distance Megan walked after 5 hours? If she's walking 3 miles per hour, what is the distance that she walked after 5 hours? So a way to represent that, right, is that her total distance is going to be equal to 3 times per hour. Is that okay? Right there. So what is the total? What is the distance Megan walked after 5 hours? So we're just going to put it into this relationship, into this equation that we have, right? D is equal to 3H. We're going to replace the H with 5. So how many? What's the distance that Megan walked? What's 3 times 5?
3 times 5. 3 times 5 is 15.
Okay, so she walked 15 miles.
So she walked 15 miles in 5 hours?
Correct.
Wow, that's a lot of walking.
That is a lot of walking, right? 5 hours is a long time to be walking, but 3 miles per hour is the normal rate that a person walks. but I would not be walking 5 hours normally. So I don't know why.
I don't know about that though, Mr. G, because you got certain people got certain people, they got certain straps in their legs where sometimes they're actually, either undergo the count or they beat the count.
Yeah, I mean, but yeah, 3 is still the average, right? So that's, yeah, it definitely varies, but 3 is definitely the average. All right, so what we can do now is complete this table of distance, right? Using this formula, we should be able to figure out the distance that she goes after a certain number of hours.
I'm sorry, Mr. G, do we got this table right here that you're doing with us?
This is practice number 1.
Okay, I got you.
Okay, so remember to fill out your hours based on, we're going to start with 0 and we're going to try to go up to 5. So we might skip a couple numbers in between there because we only have a certain number of blocks. But I'm going to start with 0 hours, right? Because it's important to demonstrate what 0 looks like. We're going to look at what 1 looks like. We'll look at what 3 looks like, what 4 looks like, and also what 5 looks like. So 0, 1, 2, 3, 4, and 5 are the hours that I've chosen.
You said 2. You got a 0, 1, 3, 4, 5. You said 0, 1, 2, 3.
I did not.
Oh. Oh, I thought that's what I heard. I'm sorry. All right, so that's the distance.
Okay.
So that's how many hours they walking.
So yeah, we're gonna look at the
Alright.
distance for all of those different hours: 0, 1, 3, 4, and 5. Okay. We want to use 0 because 0 helps us establish our rule. 1 solidifies the rule, and 5 is what they just asked us about. So that's why those are the important ones. And I just chose 3 and 4 to fill out the table. Okay.
Okay.
So if she doesn't walk for any hours, what's her distance? How many miles? What's 3 times 0?
3 times 0. 3 times 0 is 0. Cause
Yes, that's true. Right?
right.
Okay. So her distance is 0 miles, right?
Uh-huh.
Okay. Okay. After 1 hour, how many miles has she walked?
3 miles.
3 miles. After 3 hours?
9.
6.
9.
9. Oh,
3 times 3?
9.
Good. All right. After 4 hours?
12.
Good. And of course, we just did 5, right? Okay. Great. All right. So we have our table. Okay. This is how we work out these tables. This is how we work out this information. All right. What we're trying to do is establish this relationship and make this relationship make sense to us, right? So if she's going 3 miles per hour, we should be able to figure out how many miles she walks if she walks for 25 hours, right? Which she wouldn't do, but you can still figure it out, right? Because you have this information, you can use this, what you have here, all right? Once you have this information, you have your table, you can use your table, okay, to fill out a graph. Remember that in order to fill out a graph, right, of values like this, you're always going to make sure that you use your independent variable, in this case, our hours, as your X, and your distance, your dependent variable as your Y, right? So that means you're going to graph the hours along the horizontal axis, and you graph the distance along the vertical axis, right? So that's what we're going to do here. You can see it's already labeled the time in hours, and then your distance is over here on the left, okay? And it says distance is going up, D-I-S-T-A-N-C-E, okay? All right, so we're going to plot our points. We can use our drawing tools to help us plot our points. All right, so I'm going to use red. All right, so I have the first point is going to be 0, 0. So it's going to be here in this corner. That's my first point. I'm going to make it a little bigger. Okay, my next point is 1, 3. So I go to 1, then I go up to 3. Notice there's no 3 on this graph, but there is 2 and 4. So where do I put 3? 3 is going to be in between 2 and 4. All right, my next point is 3, 9. So I'm going to go to the 3 and go up to 9. Again, 9 is not on my graph, so I go in between 8 and 10, make my point. 4, 12, and 5, 15. Okay, so now I've plotted all of my points, and I can use my shapes tool to do a line, right? This is, go to shapes, select line, and I'm going to start it from this point all the way to this point. Notice it goes through all of my points that I plotted, and I've now drawn my line, right? I can even fill in the answer for 2. We know that 2 times 3 is 6, and it also falls onto my line. That's how well I did my graphing. Look at that. Bam. Okay, you've now graphed your information. Okay, the point here is that we can use your equation, your table, or your graph, right, to get all of this information about Megan and her relationship to walking, right? We know a lot of information based on what was given just by this sentence. Megan walks 3 miles per hour. We have a lot of information. Just based on that one sentence, we can make an equation, a table, and a graph. Okay, so then the question that's asked here in letter E is, would you use the table, the graph, or the equation to predict how far Megan walked after 24 hours? What would you use? Anybody, what would you guys use?
I would use basically sometimes I would use graph basically just
Okay, you would use the graph?
yeah.
Okay, if you
And
use
then
the graph, you'd have to make it bigger, right? Because it doesn't go to
Right.
24 right now,
now,
okay? So you could use the graph, but you have to make it a lot bigger,
yeah.
okay? All right, anybody else? What would you use?
I'd use the equation because it's just simple, sweet, and to the point. You know, simple. Just throw the numbers in there and get it out the way. You don't have to do all the little points on the graph and make it bigger. It's too much work with the graph.
Yes.
So if they were asking us a question about a number that was already on the graph or already on the table, it would make much more sense to use the graph or the table, right? We can use any of them to get that answer, but as Ebony just said, we have to do a lot of work to get out there to 24, because right now we only have 0 to 5, right? So what's going to be much easier is if we use this equation, D is equal to 3H, replace that H with 24, and we're going to get our answer, right? So the equation is always going to be the most efficient. Right? And so we can just do that right here. D is going to be equal to 3 times 24, right? And 3 times 24 is going to give us 72 miles. She's not going to walk 72 miles, but if she did, it would take her 24 hours. That's assuming she doesn't stop and she's some sort of superhuman who doesn't need food or water, right? But 72 miles, she could do it in 24 hours, okay? Right? And again, all of that information comes from just this one sentence that tells us that she walks 3 miles per hour. okay? So we can turn just that one little bit of information into an equation, a table, and a graph. Your equation is always going to be the most efficient, right? And that's why we're trying to move on from this idea of using tables, move on from the idea of not using variables. We have to get into this habit of working through what is going to become algebra, right? This is our pre-algebra essentially moment here where we're just like, we're getting the idea and the hang of working with variables so that we can make our math easier. All right, let's try number 2. Oh, well, number 2 actually still has to do with Megan. Never mind. Charlie said that a graph is the best way to predict how far Megan walked after 24 hours in question 1. Why is Charlie incorrect? We already talked about why Charlie's incorrect, right? Because it's just going to take too long, right? We have to extend our graph too much. The graph needs to be extended or it can be used to predict 24 hours. Right, so we have, it's not great. All right, always use your equation. Your equation is going to be the best option for you. All right, now let's get into the second problem because this first problem is done. We've talked about Megan and what she can do. So now we're going to try this next one. All right, this is the equation t equals 3 plus 2h represents the total cost to use the internet for h hours. All right, so we have our equation, right? Our equation's right here. I'm just gonna. Okay, here's our equation right here. T equals to 3 plus 2h. I do have my highlighter. Okay, that's my equation. I have my table here on the left. I have my graph here on the right, right? Equation, table, graph. All right, so how would I use the graph to find the amount of time, the amount spent, excuse me, right? How much I've spent after 3 hours on the computer? How could I use the graph to show me how much I've spent after being on the computer for 3 hours? How can I use that graph? What would I do? So here's my graph. How could I use it to tell me how much it would cost me to use the computer for 3 hours? So what I would do is I would go to the 3 on the horizontal axis because that represents hours, right? It says time and hours. I go to the number 3. And then I go from the 3 up to where the 3, right? This line for 3 intersects with my graph. And it's about right here, right? Once I find that point, which is already labeled, I go over to the left side of my graph, the y-axis, and see what number that is. Oh, it seems to be about $9, right?
9.
Okay, so that means that for 3 hours on the computer, it's going to cost me about $9. Okay, so that's how I read the graph, right? You find the location on the x-axis, see where that point on the x-axis interacts with the graph, and look for the y value. Okay, that's how I'm going to use my graph. Okay, x-axis 3, go up, find the point, and see where it interacts. Oh, it's going to cost me about $9. Okay. Right. Okay. I didn't have to really do any math to do that, right? I went 3 up to the graph, over to the y. It could be that I'm off. It could be that it's not exactly 9, but I'm using the information that's given to me. Okay. What about in part B? It says Maria spent $10 on the internet. $10 on the internet, yes. So how long did she use it? What information can I use? I have a equation, I have a table, I have a graph. She spent $10. So how long did she use the internet? And how do I know? $10.
I'm wondering if you actually could start how you actually just did the last one.
Okay,
If you started at the 3 and you went up.
okay.
So that's how I was actually looking at it. That's how I got that's how I got my answer.
Okay, but in this case, we're looking for the hours, right? So where would you start? So I started on the x-axis, right?
Right.
Because I was looking for the y value. But this time you're given the y value and you're looking for the x value. So how do you start? So she spent $10. So where do you go?
You go to the hours now. Right?
So she spent $10, right? So you're going to start at the 10 on the y-axis, just like I did with the 3 on the x-axis, because I knew how many hours, right? So I'm going to start with that $10, and then I'm going to go to see where that $10 intersects with my graph. Where does it intersect? Oh, it intersects right here. What value of that? What's the value on the x? It's right here. So what value is that? It's in between 3 and 4. So how many hours did she spend on the internet?
About 3.5.
About 3.5, right? That's one way to do it. Okay, and that's a good way to do it. Yeah, you can use your graph. Okay, so you can put that down as your answer, Deontay, because you can use your graph. Is there another way to do it?
I believe it is.
Okay, well, you already gave your answer, so you're good. Anybody else have another way to get the answer? She spent $10 on the internet. How long did she use the internet? What else could we do?
Is it so I already gave you my answer.
You trying to help everybody else out?
No, it's not that. It's just honestly, I honestly want to figure out another way you can do it, because I don't want to just find out one way and all along I probably can do it another way that I probably find more easier.
There's 2 more ways.
So there's actually 3 ways.
Yep.
Jesus. All right, so
we used the graph, right? We went to $10 on the graph and then went across to the graph to see where the hours are. What else can we do? Oh, somebody put something in the chat. See, I wasn't. Yeah, we can use the equation. Sorry, Toya. Yes, Toya is correct. We can use the equation, right? So I have my equation says t equals 3 plus 2h. So that t, I just replace it with 10. So I have 10 is equal to 3 plus 2h. Okay, I'm going to subtract 3 from both sides in my equation. I'm going to use my marker here to show this. All right, so when I have an equation, in order to solve it, I'm going to try to solve for that h. I want the number of hours, right? I'm going to subtract 3 from both sides. Now I have 7 is equal to 2 times h. Divide both sides by 2. 7 divided by 2 is 3.5. So that's another way I can use my equation. I can use my equation. I can use my graph. What's the final way? What's the final way?
Table, you can.
Yes, I can use my table, right? I have my total cost right here on the right in my table. I can look for $10. Oh, I don't see $10, but I see 9 and I see 11. 10 is right between 9 and 11, so that means the number of hours that she used, that she spent must have been between 3 and 4, which is 3.5. All right, so those are your 3 ways. You can
I
use
got
your
you.
table, you can use your graph, or you can use your equation, whichever you are most comfortable with, right? Those of you who are powerhouse people who are ready for that algebra can jump right into that equation to figure out how to get your answer. Those of you who need a little bit more time to get there can use your graph, right? Because the graph tells you that same information. You just go to $10, see where it interacts on the graph. Look, oh, okay, that seems to be about 3.5. Or you can use your table, which gives you the information in a very easy to read formula that you just have to, in this case, do a little bit of figuring out where you have to be like, oh, well, in between 9 and 11 is 10. So in between 3 and 4 must be 3.5. You had a question, Deontay?
Right back to the equation part. I was getting ready to say, did you subtract both sides by 3?
Yep, always. Whatever I do on one side of an equation, I have to do to the other side of the equation.
Okay.
Right? So it started off as 10 is equal to 3 plus 2h, right? I need to combine the 3 and the 10 because they are alike, right? They don't have a letter with them. In order to combine them, I have to move this from this one side to the other side. Right now it's a positive 3, so the opposite of positive 3 is?
Negative.
Negative 3. That's the way to get rid of it. So 10 minus 3 gives me 7. So now I have 7 is equal to 2h, right? I want the h by itself. Right now it's being multiplied to 2. What's the opposite of multiplication? Division. So I have to divide both sides by 2. 7 divided by 2 gives me 3.5. That's how I got 3.
Okay. That wasn't so difficult.
None of it is difficult.
Because that 7 equals 2h, you did it. You actually instead of subtracting it, you actually divided it, but you still did it the same way. The only difference is you divided it instead of subtracting it. Like here, how you put it right under each other, like how the 10 equals 3 plus 2h.
Yep.
And you subtracted both sides. And then when you got your 7, and it became 7 equals 2h, and then you divided both sides by 2.
Yes.
That's how I'm saying it.
Okay. All right. As long as it's making sense to you, yes, that's good. Yes, perfect. All right, that is the second part here. Let me see. Let's make sure there's no more questions that I need to scroll down and do. All right, but so you can use whatever you used. Your answer is going to be, like I said before, your answer is 3.5, right? So h is equal to 3.5. Make sure you put the method that you use to get that answer, right? Either the equation, the table, or the graph. All right, so after 8 hours, how much will Maria spend on the internet? Again, let's go back up. We have the equation, we have the table, we have the graph. We can use all 3 to get that answer. 2 of them is going to be easier than 1 of them. But if she spent 8 hours, how much is it going to cost her?
It doesn't say. No.
So after using that table, that 8 is not in there for the hour, so that's definitely that shit is increasing. So
22.
Yes, it is going to be 22. What did you do?
Okay, she said 8 hours. If you spend $11 for 4 hours, all you have to do is double that, giving you 22.
Hey, right? We can use the table. The table gives us 4, right? 4 times 2 is 8. So all I have to do is multiply this 11 by 2 to get 22, right? I can use my table is going to be a really easy and straightforward way to get that answer, right? So 22, good. What's the other easy and straightforward way? Besides using the table, am I going to use the equation or the graph? What's going to be easier?
the equation.
The equation. You just replace that h with 8. What's 2 times 8?
Huh?
What's 2 times 8?
16.
16.
Okay, what's 16 plus 3?
19.
It didn't work. Oh no.
You said 16 plus 3?
38.
38.
No,
I
you,
don't know,
no,
my audio
wait,
fucked
you
No,
guys did-
48.
Whoa, what happened? Wait, calm down, calm down.
Mm,
I think I'm
Where did all these numbers come from? You guys were right the first time. What happened? What happened? Oh no.
Oh no, it's like numbers just start flying.
Some numbers
19?
you guys were right the first time. What are all these other numbers?
No, I just said no. I said
36,
48. Begin with that
40.
one.
Okay,
Because 16 times 3 is 40.
okay. Hold on.
It says times.
All right. So we were right the first time, okay? So here's your equation, right? 3 plus 2 times 8, right? 8 times 2 is going to give us what? 16.
Oh,
16 plus 3 is
16.
19. Your
19.
correct answer here is actually going to be the 19 and not the 22 because this table, even though it gives us good information, what we're figuring out here is that it's not proportional, okay? This is not a proportional relationship, which is what I wanted you guys to see here. I normally can just double whatever I do to get my same answer, right? 4 times 2 should give me 8. 11 times 2 is going to give me 22, right? But that's only in a proportional relationship. This relationship is not proportional. So it's not like our previous one that we were working with. How do I know it's not proportional? Because it does not interact with the point 0, 0. Also, I can look just right here. What's 1 times 2? 2, right? So 5 times 2 should give me 10, but instead it gives me 7. This relationship is not proportional. So normally, while I would be able to use my table to get my answer when I have numbers that don't appear on the table, in this equation, because this relationship is not proportional, I can only use my equation to get the correct answer. That takes nothing away from the answer that Ebony gave me because I led her down that path, right? I wanted her to try to make those connections because in general, you can make those connections. Here, this relationship is not proportional, so we can't use that connection. We can only use the equation, okay? Only the equation is going to give us the correct answer here. So we must use the equation for that question, for a number, whatever it is. Let's go down. Let's scroll down and see where it is. But after 8 hours, how much will Maria spend on the internet? We have to use the equation. So I'm going to put the equation in here, right? The equation is T is equal to 3 plus 2H, right? We have to replace that H with 8. So we use T is equal to 3 plus 2 times 8, okay? And that's gonna give me 19. 19 is how much she's gonna spend on the internet after 8 hours. But she should not be spending 8 hours on the internet unless it's COVID times, which then you spend 24 hours on the internet. But that's a lot of money to be spending for only 8 hours. All right, so sometimes we have relationships that are proportional and sometimes relationships are not proportional. All right, we can tell if a relationship is proportional, one, by looking at the graph. If the graph goes through 0, 0, it's a proportional relationship, right? We can also check to see if the relationship is proportional by seeing how we are advancing. For instance, 1 hour to 3 hours. How do I get from 1 to 3? I have to multiply by 3. So that means the distance should also be moving in that same relationship. 3 times 3 gives me 9, right? Oh, it does. So this relationship is proportional. Here, this relationship is not proportional, right? Because once again, our graph doesn't start at 0, 0, right? Our graph doesn't even go through 0, 0, right? And also when we look at our table, to get from 1 to 2 is just a multiplication of 2, right? 1 times 2 gives me 2, but 5 times 2 should give me 10, and it's not 10, it is 7. The relationship is not proportional, so I can't use anything but the table, but the equation, excuse me, to get the correct answers, all right? The table is not gonna help me in this situation. The graph would if it was extended, but it's not extended. So that I can't just predict. I have to keep going and counting up the right way, okay? All right, here's a new equation for number 4. The equation T equals 10 plus 5H. T is the total cost to park in the garage for H hours. What is the cost after 6 hours to park in that garage? T equals 10 plus 5H. What's the cost to park in that garage after 6 hours? You got to replace that H with the number of hours. So what's my answer going to be? Ooh, I see an answer in the chat. Let's see. Toya says B. Does anybody agree with her?
Am I gonna say yes? I mean, oh,
Okay, so 5 times 6 is going to give me 30. 30 plus 10 is going to give me $40. So that is correct. Good job, Toya. And everybody else who got that answer. All right, we've got a lot more to do. Let's keep going. All right, I don't know. How did he get 30? What did he do? If you chose answer A, you might have not remembered to add the 10, right? You might have just done the 5 times 6 and forgot about the 10. So always make sure you're using your equation and looking back at your equation so you have all the pieces. Our tendency is to be like, oh, let me replace the H with 6 and now I'm done, right? Just 5 times 6 give me my answer. Don't forget that there is a 10 there. That's why it's 40 and not 30. That's the answer to number 5. All right, let's look at Marquise and his cupcakes. All right, so each cupcake costs $2.75. So he has to buy some cupcakes for a party, for a class party. So let's fill in a table here. So how many cupcakes do you guys think he's gonna buy? How many cupcakes would he need for this class? How many people are in this class right now?
Like 6. I don't know.
So what? I don't get a cupcake, Marvin?
Well, yeah,
I'm
7.
not a
No,
person?
No. Come on, guys, it's 7.
Oh,
7. No,
wow.
no, 7. No, I meant to say 7. No,
Oh my goodness. Okay, Marvin. I see how it is. I see how it is,
no,
Marvin.
no, Jackie. No.
I'm just messing with you, Marvin. It's okay. All right. So if he buys 0 cupcakes, it's not going to cost him anything, right? Right. That's going to be our first point. Let's say let's use the numbers 2, 5, and 10, just to see how it goes. So let's do 2, 5, and 10. If he buys 2 cupcakes, how much is that going to cost him? They're $2.75 each. How much is that total?
They're gonna be $5.50.
Okay. It's going to cost him $5.50. What about if he buys 5 cupcakes?
$5.50. Okay, so $5.50.
Those are gonna come to $13.75.
Okay. All right. And we are finding out these answers, right? All just by multiplying the number of cupcakes times 275, right? So this is the equation that we're using, right? The price of the cupcakes times the number of cupcakes gives us the total money it's going to cost. All right. So if he buys 10 cupcakes, how much is it going to be?
$27.50.
Perfect. All right. So this is our table that we've created. We can use this table now to fill out our graph, right? We are just going to go with 0, 0, then we're going to go to 2, and we're going to get to 550, right? Again, we have to make some estimations here, right? It's not going to be exactly on the line. Hopefully we won't be too off, but let's say it's about right here. 5 and then 1375. It's going to be somewhere here. Okay, oop, more on the line, excuse me. And then 10 is going to be 2750, which is directly in the middle between 25 and 30. All right, so we have a line there. This is our graph. More or less. Okay, so we have our table, we have our graph. This is the equation that we're using, right? Let's see if we scroll down here. Okay, we're going to put the equation into part C. Let me go ahead and clear it from here and put it into part C. All we did was say that our money is going to be equal to $2.75 times every cupcake that we purchase, right? Because 1 cupcake is going to cost $2.75. 10 cupcakes is going to cost $27.50 because 10 times $2.75 is $27.50. All right. All right, Marquise is big ballin' though, right? Because he has $30 to spend. So how many cupcakes can he buy with $30? We can use our equation, right? Which is what we're going to do because we are now some algebra buffs here, right? Algebra is, we're not playing any more games. We have M is equal to $2.75 times C. So because he has $30 to spend, we're going to replace that M with 30. So we say 30 is equal to $2.75 times C. So how do we solve that equation? We're trying to get the C by itself. So what do we need to do to solve that equation? How do I get the C by itself? To get the C by itself, I need to divide both sides by 275. Okay, so I have to do 30 divided by 275. It's going to cancel out the 275 on this side. So I'm going to get my answer for C. So it's 30 divided by $2.75. It's going to give me something like 10.9. Can I buy 0.9 of a cupcake? Can I go to the bakery and be like, I only have enough for 0.9 of a cupcake? Are they going to chop it up for me?
No.
They are not. So he is only going to be able to get 10 cupcakes for his $30.
That's taxing. Them cupcakes better make people fly.
$2.75 a cupcake. That's cheap in DC. But I mean, you know, we're beyond the cupcake craze now, but the cupcake craze happened about 10 years ago, I want to say. It happened about 10 years ago, lasted for about 3 years. And cupcakes were anywhere from $3 to $4 a piece. And they still continue to be about $3.25. But they're no longer like on every corner. Everybody's not like advertising, oh my, I got cupcakes, we got cupcakes, blah, blah, blah. It was a problem for a minute. Okay, all right. For part C, we can get the same answer to part D. Actually, in part E, I'm sorry, we can get the same answer to part D. I'm pretty sure they want us to get the answer to part D by looking at our graph, right? If we look at our graph here, we can look at the 30 and see that our graph is not going to get us to 11, right? It only gets us to just over 10. So that's how we can get the answer as well. All right, so what's left for you guys to try is this last page on your own using the same information that we did before. So if you have not yet finished practice 1, or if you tried practice 1, please go back and redo it so you get the correct answers in for practice 1. But I do need practice 1 in today, as well as your notes uploaded today, right? We finished our notes today, so those should be finished and uploaded. Practice 1 should be finished and uploaded. And then the only other thing that would need to be done, yeah, so make sure both practice 1 and practice 2, which is on the coordinate plane, are done today. So all the things that are in your folder, intro, practice 1, the intro to graphing notes, practice number 1 and practice 2 should all be done today. Everything else that I have not released to yet will not be released, and it'll just wait until we do our next section of graphing, which is going to be next week. And that is the plan for today. So make sure you do everything that's in your folder. Everything that's in your folder is due today. That means you have until 3 o'clock tomorrow to turn it in, right? After 3 o'clock tomorrow, I'm going to put attendance in for today. So you won't be able to get credit for anything that you've done, but make sure you have your notes turned in, practice number 1 turned in, and practice number 2 turned in. Okay?
All right.
All right. So have a very happy holiday. Stay safe. And if you can, stay home. All right. I will see you all on Monday.
Okay.
Hi, happy holidays,
You
everybody.
do the same, everybody.
Hey, Mr. G.
Happy Thanksgiving for everybody, by the way.
Yep. Happy Thanksgiving.